Hey guys, in this video we're going to be taking a look at some different parts of a circle. We're going to take a look at central angles, inscribed angles, and intercepted arcs. And if you remember from the last video, central angles are an angle in a circle that has a vertex on the center and the endpoints on the center. So this right there, angle A, would be a central angle. An inscribed angle is an angle in a circle that has a vertex on the edge of the circle and endpoints on the circle. So a central angle, an inscribed angle would look something like that. So we're going to take a look at rules that go along with those and how to solve values for those, as well as how to get values for an intercepted arc and the definition for what an intercepted arc is. So to start off, looking at our central angle words, to find the degree measure of a minor arc, it's going to be equal to the measure of its central angle. So if we look, the central angle for this circle A is angle A. So angle A is going to be equal to the measure of arc BC. So whatever that angle there is, that's going to be exactly what the measure of that arc is going to be. They could also talk to you about adjacent arcs. So there's a couple different options that we have in that circle, but if we're looking at adjacent arcs, we've got arc BC as an arc, and then we've also got arc DB. So you could say arc BC is going to be adjacent to arc DB. And it's just a way to say they're right next to or beside each other. You could also say BC is adjacent to DC. You could also do DB is going to be adjacent to DC. There's lots of options on there. Just as long as they share a common endpoint, you're good. And with that, with them sharing those common endpoints, you can have your arc addition postulate. So the measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. So if we're looking at that, let's say we've got DB and BC. If we do the measure of arc DB and add it to the measure of arc BC, that's going to give us the whole major arc of DBC. And this goes along with our segment addition postulate and our angle addition postulate. It's pretty much the part plus part is equal to total. And with this, it's not just restricted to part plus part. Like for this circle, we could also throw in DC and calculate values for DC. And if we did that, we would do the measure of arc DB plus the measure of arc BC plus the measure of arc CD is going to be equal to the measure of arc, you could go DBD or you could go DCD, it doesn't matter. And if you notice, it starts here and ends there, which means we have a whole entire circle, which is going to be equal to 360 degrees. So if they have you doing things with parts of a circle and they give you either central angles or arcs to add together and to solve for one, you're going to be using that arc addition postulate and setting everything equal to 360, because that's what a circle is equal to. If you start here and go all the way around, that's going to be 360 degrees. Looking at the next vocabulary word, starting to get into our intercepted arcs. An intercepted arc is a portion of the circumference of the circle located on the interior of an angle whose endpoints lie on sides of the angle. So if we're looking at this, it basically says, okay, the angle what part of the circle is on the inside of the angle. So if we look here, here's the angle, angle A. Arc BC is intercepted by angle A. You could also do an inscribed angle and have it so you could go arc XY is intercepted by angle Z. Those are both considered intercepted arcs. Okay. And then on to our inscribed angle, looking at our inscribed angle theorem, the measure of our inscribed angle, and in this case we're looking at angle D, is going to be equal to 1/2 of the measure of the intercepted arc. And in this case, our intercepted arc, here's our angle. So angle D is going to be equal to 1/2 of BC. So angle D is equal to 1/2 of BC. And remember, they could give you problems where they give you this angle here. Remember, this angle is equal to that angle. Or sorry, this angle is equal to the measure of that arc. So if angle A is equal to 24, and angle, that means arc BC is going to be equal to 24. And then angle D would be 1/2 of BC, so 1/2 of 24 would be 12. And then looking at parallel lines congruent arcs theorem, parallel lines intercept congruent arcs on a circle. So looking at this one, they would have to tell you either in the problem or by showing you in the picture, but I'm going to tell you here, CD is going to be parallel to AB. And if you know those two things, then you can say angle COA is going to be equal and congruent to angle, so we did COA DOB. So that tells us that this angle right here is going to be the same exact measure as that angle right there, given that line is parallel to that line. So if we start trying some of these out, looking at the first example, it says, what is the measure of angle FIG? So if we go and we find FIG, there's FIG, we're looking for that angle right there. Well, that's the only angle that we don't have a measure for. And if you remember, all the angles in a circle are going to add up to be 360 degrees. So this is where that arc addition postulate comes in. So we've got this angle, so FIE plus angle EIH plus angle HIG plus angle GIF, and I'm going to name it FIG so it matches up there, is going to be equal to, forgot to make that an E. That's good. All four of those angles added together are going to be equal to 360 degrees, which is our circle. So if we start plugging in the values, FIE is 105 plus EIH is 110 plus HIG is 70 plus FIG is the angle we don't know, so we're going to leave it FIG. So add together the 105, 110, and then 70, and we get 285 is going to be added to angle FIG, and those two added are going to be 360. Subtract the 285 from both sides, and we get angle FIG is going to be equal to 75 degrees. So that angle right there is 75. And if you want to double check, you can take all four of those angles, add them together, and if you've done your math correctly, they'll equal 360 degrees. But they're not always necessarily going to give you number values. They could give you algebraic values as well. So same exact process, just instead of only having numbers, we could have variables too. So if we work with this one, we've got angle KHJ plus angle JHI plus angle KHI. And that's going to be equal to, we're making a circle, so it's 360 degrees. So we know angle KHJ is going to be 89 plus JHI is going to be x plus 63 plus x plus 38 is going to be equal to 360 degrees. So combine our x's and we have 2x plus 89 plus 63 plus 38 is going to be 190 is going to be equal to 360. Subtract the 190 from both sides, and that's going to leave us with 170. Divide both sides by 2, and x is going to be equal to 85. And with these problems, you've got to be very careful and check and see whether they say what is the value of x versus what is the value of angle KHI. And if they wanted KHI, you'd have to take the 85, plug it back into x, so add 38 to it, and that would give you your angle there. So just to keep an eye out, be very careful for what they're looking for, because they're going to start mixing it up. And if you're not careful, you get the answer wrong. So looking at this one, this is an example that I was telling you about where they give you a circle to solve for, and instead of asking for what the value of x is, they're going to ask you for what the measure of angle DHE. So we're looking at DHE. DHE is right there, so that's the one we're trying to solve for. So we're going to do our angle addition postulate, and at this point I'm not going to write the angle names down. Instead of equal to 360, I'm just going to take the values that they give for the angles and add them. So we're doing 2x plus 2x plus 51 plus 4x minus 5 plus 82 is going to be equal to 360 degrees. So combine our like terms. 2x and 2x gives us 4 with 4 more is 8x, and then (51 minus 5 plus 82 gives us 128 equal to 360. Subtract the 128 from both sides. So 8x is going to be equal to 232. Divide both sides by 8. So x is going to be 29. That's not our answer because we're looking for DHE. So we've got to take that x, plug it back in there. So we're doing 2 times 29 gives us 58. So the measure for angle DHE is going to be 58 degrees. So looking at the next one, we want to know angle SRT. So SRT. So with these, this is where the vocabulary really starts coming into play on knowing what the words mean and knowing what values that's going to give you based on where it is in the circle. So if we look, SRT is a inscribed angle. And the only part that they give us values for is 69 right there for angle Q. So this is an inscribed angle. The inscribed angle, so angle SRT, if we use that definition for our inscribed angle theorem, that angle, the measure of the inscribed angle is equal to 1/2 of the measure of its intercepted arc. So if we look and we find the intercepted arc, that's going to be the parts where the angle intercepts the arc, or where the arc is between those two angles. So SRT is going to be equal to 1/2 of arc ST. But if you look in this picture, they don't give us arc ST. What they do give us is angle SQT. And using our definition, see where we're using all these definitions, using our definition of the degree measure of a minor arc, it's going to be the same as the measure of its central angle. So the central angle is equal to the arc. So here we've got angle SQT, so that angle is going to be equal to the arc that we need, ST. So angle SQT is 69 degrees, and so that's going to give us our measure of arc ST. So angle SRT is going to be equal to 1/2 times 69. So the angle of SRT is equal to 34.5. So you see how we took that central angle. The central angle is going to be equal to that minor arc. And so this inscribed angle is going to be half of that intercepted arc there. Looking at the next one, what is the measure for angle D? So this one's kind of just a reverse of the one we did above. We're still using that rule, the inscribed angle. So in this case, the inscribed angle is going to be angle FEG is going to be equal to half of the intercepted arc. And if we look and we go up this way, the arc is going to be FG. So angle FEG is 33, is going to be equal to 1/2 of FG. Well, got to solve for FG. So to do that, we're going to multiply both sides by 2. 33 times 2 is 66, is going to be equal to FG. But we don't want FG, we want the measure of angle D. So we know the measure of angle D using our degree of a minor arc rule. The measure of that central angle is going to be equal to the intercepted arc. So measure of angle D is going to be equal to the intercepted arc FG, and we know FG is 66, so that's the measure of our angle D. So our angle D is right here. And its measure is going to be 66 degrees. Okay. Looking at the next one, now you're going to get to a point where they're going to start combining more of these ideas together. So combining the ideas of what we were doing with the sums of those central angles and what we were doing with the intercepted arcs with the central angles and the inscribed angles. So you're just going to need to keep all the definitions straight and focus on what you need, what information you have, and get yourself where you need to be. So with this one, we're looking for angle HJI. So HJI. So that means we want this whole intercepted arc right here. So I know that angle HJI is going to be equal to half of HI using that inscribed angle theorem. Well, in order to be able to solve for HJI, we'd have to know HI. Well, we don't know HI. What they do give us information for is they give us the 144 and the 22. We would really like to have that angle because we know the measure of arc HI is going to be equal to angle IGH. Well, in order to find IGH, we could add those three angles together, set them equal to 360, and solve. So we're doing 144 plus 122 plus angle IGH, which is the one we need, and all those together are going to be equal to 360 degrees. So I take the 360, 144 plus 122 is going to be 266. and then subtract that from 360. Angle IGH is going to be equal to 94 degrees. So that means this one right here is going to be 94, which means the measure of this arc is going to be 94. So this is 94, so that's going to be arc HI. And then now that we have arc HI, we can plug it into, so we started here, we went to there, we got that value, went back up to there, and now we're going to plug it in over here. So HI is 94, is going to be equal to angle HJI. So half of 94, so angle HJI is going to be equal to 47 degrees. Okay. So if we try some more, what is the measure of angle RST? So here at this point, they stop giving us whole numbers to work with, and we start relying more on our intercepted arc theorem, our inscribed angle theorem, in order to be able to solve for these. So they want us to find the measure of angle RST. So if we look, RST is right here. So this angle right here is 8x plus 45. That angle right there is 6x plus 100. So using our inscribed angle theorem, we know that angle RST is going to be equal to 1/2 of arc TR. And remember from the degree measure of a minor arc definition, we know arc TR is going to be equal to angle TQR. So we don't have a value for TQR. We can't find an exact value, but we have an algebraic expression. So instead of angle TQR, we could write arc TR is going to be equal to 6x plus 100. Well, we can substitute that in over here and say RST is going to be 8x plus 45 is equal to 1/2 times TR is going to be 6x plus 100. So there's two ways we could go about solving. We could either multiply both sides by 1/2 to have that 1/2 be over out of the problem, or we could just multiply by 1/2. So 8x plus 45 and distribute this 1/2 here. So half of 6 is going to be 3x plus, be careful, make sure you distribute to both, 50. So now it's just an algebraic problem where we're solving. So subtract the 3 from both sides, 3x, and left with 5x plus 45 is going to be equal to 50. Subtract the 45 from both sides, and 5x is going to be equal to 5, and then x is equal to 1. And this is some of where I was telling you, be careful. Don't just get a value and then say, okay, done. If you look, it wants the measure for angle RST. And angle RST is equal to 8x plus 45. So we've got to substitute in that x and solve. So angle RST is going to be equal to 8 times 1 plus 45. So angle RST is going to be equal to 8 plus 45. So angle RST is going to be equal to 53 degrees. And then they could give you pictures where you're working with arc lengths. So if we're looking at arc lengths, and the reason why I know we need an arc length is that's what they give us information for, and it asks for angle I. Angle I is an inscribed angle, and if we're using our inscribed angle theorem, angle I is equal to 1/2 of its intercepted arc. So that actually goes from K all the way over to J is the intercepted arc. Well, they don't have any other information for this circle other than arc KI is equal to 65 and arc IJ is equal to 61. And if you remember, central angles are equal to the intercepted arcs. Or sorry, central angles are equal to arc measures. They don't give us any central angles, but we know that the central angles in a circle add up to be 360. That's the same for the arcs too. The arcs in the circle are going to add up to be 360 degrees. So we could just go 65 plus 61 plus arc KJ is going to be equal to 360 degrees. So 360 is going to be equal to 126. So arc KJ is going to be equal to 234 degrees. So this whole big arc is 234. So we know our intercepted arc, our inscribed angle is going to be equal to half of the intercepted arc. So angle I is going to be equal to 1/2 of 234. So take the 234 divided by 2, and angle I is going to be equal to 117. Looking at this next example, it's kind of the same exact idea. We're looking for what is the measure of angle R. They don't give us very much information. All they do is they give us an arc measure and expect us to be able to solve. With this one, this is where the definition of a semicircle comes in really handy. And the way we know that we have a semicircle is because we have this line that we know is a chord because it goes from one side of the circle to the other. And we know this chord is a diameter because it goes through the center. Remember me telling you they've got to show that center point in order for you to know for sure that you've got a diameter? This is an example of where they do it. If you have that, then you know that from there to there, you also know this is a straight line. You know a straight line is 180 degrees, and remember the central angle is going to have the same exact measure as your intercepted arc. So that's going to be 180 degrees. So that lets you be able to solve. So then you've got 65 plus 180 is going to be added to arc, the intercepted arc PQ, and that's going to be equal to 360. Subtract it from 360. Gives us 115 degrees, so this is 115, but we're looking for angle R. Angle R is a inscribed angle, and it's equal to half of its intercepted arc, which in this case is PQ. So angle R is going to be equal to 1/2 of 115 degrees. So angle R is going to be equal to 57.5 degrees. Looking at the next one, this is where it starts. You've really got to focus on what they ask you, what they give you, and what you need to get there. So we're looking at EGF, EGF. So we're looking for this value right here. That's a inscribed angle. So we know this inscribed angle, angle EGF, and we're using that inscribed angle theorem, is going to be equal to half of FE. Well, there's that intercepted arc FE that we would need a value for. It would be really nice if we had that central angle there, but they don't give that value to us. Again, it's a semicircle, means that's 180 degrees. So we can do 180 plus 98 plus angle FDE is going to be equal to 360. So So 360 is going to be equal to 278 plus angle FDE. Subtract the 278 from each side. That gives us 82 is going to be equal to angle FDE. So if this is 82, that means this one is 82. And so angle G is going to be half of that arc. So half of 82 is going to give us our angle EGF. So angle EGF is going to be equal to 41 degrees. Okay. Next, the last one. What is the measure of arc FG? So we're looking, arc FG is right here. And there's two ways that we can find arcs, using either our inscribed angle theorem or using the degree measure of a minor arc theorem. So arc FG is going to be equal to the central angle, but we don't even know if that's a central angle. It doesn't have a dot in it. It looks like it's just a random angle. So we can't use the central angle. So the only other one that we can use is going to be the inscribed angle. So to find the inscribed angle, you're looking for the two chords that intercept whatever arc that they're looking for. So this arc right here is going to be, if we use that inscribed angle theorem, angle FHG is going to be equal to half the arc. So we know angle FHG is 45, and that's going to be half of arc FG. So we're solving for FG, so multiply both sides by 2. So arc FG is going to be equal to 90. So that arc right there is going to be 90 degrees because it's twice of what that angle is going to be, or this angle is half of that measured arc. So looking at the next one, they want, this is where they're going to start using several different inscribed angle theorems together. So with this one, they want the measure of angle T. And if we look, angle T is right here. We know angle T is equal to half of that one right there, but they don't give us any information for that one. So if we're looking, there's the angle that intercepts arc SR. There's our inscribed angle. But that's not the only inscribed angle in the circle. If you look right here, angle U also intercepts that arc. So if you have two angles that intercept the same arc, they're going to be equal to each other. So if we're looking and we want to write out a nice rule for it, angle STR is going to be equal to angle RUS. And with this, order doesn't really matter. So if this angle is equal to that angle, we can say that with the algebraic expression. So 2x plus 49 is our STR, is going to be equal to x plus 50. Solve for x both sides. X is going to be equal to 1, but this is, again, be careful. They may not just ask you to solve for x, they may ask you to solve for the measure of an angle. Angle T is equal to 2x plus 49, so then angle T is going to be equal to 2 times 1 plus 49, so angle T is going to be equal to 2 plus 49, so angle T is going to be equal to 51 degrees. So there's you several different examples of ways that they could ask you to solve for a central angle, an inscribed angle, or an intercepted arc in a circle. If you have any questions on any of these, be sure to write it down on your guided notes and ask me whenever you get to class.